Hi everyone, we are back and we are on our final problem set, our NOVA problem set, and we're going to be finishing up our Pset 8. So we're going to work with the empty cars data set, interested in how gear, carb, and am, so three variables, so I'm going to do a three-way ANOVA, affect the displacement, DISP. So these are our variables, this is basically our outcome, and we want to analyze this at a 1% significance level. So let's go ahead and get started. So what we're going to do is we're going to get into R. We are going to read in the empty cars data set. And actually we're going to Control Enter. So empty cars, that's a built-in data set that's already in R. And what we're going to do is we're going to select our variables, gear, carb, am, and displacement. We're going to set as a data frame gear, carb, and am as a factor. And we're going to set displacement as a numeric because, again, we want to treat these as variables, this as our outcome. So we're going to do that. We can do a summary. Oops. Let's go ahead and Control Enter here. There we go. Now we can kind of see. So we have gear. There's either the 3 gear, 4 gear, 5 gear. It kind of summarizes essentially the values here. And you can see here, this is going to be a numeric, so it actually analyzes this data numerically, whereas we have basically 19 instances of our AM being 0 or 1. So let's go ahead. We're going to run our three-way ANOVA. So how does displacement affected by gear, carb, and then our three-way and two-way interactions as well. So gear, carb, am, gear, carb, all those basically permutations, and then finally our three-way interaction as well. And we're going to set the data. So we can do that. We're going to get a summary of our data. So again, this tells us our degrees of freedom. It's always good to kind of double check your data here. So we see, for example, gear has 2 degrees of freedom because we only have basically 3, we're not going to call these variables, but basically 3, oops, I just plugged in my, I plugged in my power there for a second. Basically, we're not going to call these variables, but basically instances or experimental, I wouldn't call them outcomes either. But within our variable, which of these, kind of control, outcomes are going to be, significant. So we can go ahead and see that. So what variables are significant? We can actually see that here as well. So the star gives our significance codes. Remember, we're working at a 1% significance, so anything less than 0.01 will be significant. So here, gear, carb, am is not significant, and gear and carb is significant as well. Now you may be asking, well, what about we have gear, carb, we have carb, am, what about gear, am? Or what about our three-way interaction? Well, we don't have enough data in this data set to calculate this where it's significant, so it's not giving us that readout. What about the size of each variable? We can see that here. So remember, anything above 0.14 is a large effect. So we have a large effect on the gear, large effect on the carb, fairly low for am, kind of a medium impact here, and very low for these sets of variables as well, these two-way interactions. Now, what is what set of variables in experimental conditions? So again, we have a variable gear, and then there's experimental conditions 3, 4, or 5 gear. So which ones basically are significant, which would produce the highest displacement? So let's go ahead and let's look at gear. We can see here that basically we have significance between 3 and 4, but not 3 and 5, and not 4 and 5 to our significance level. You can do the same analysis here, and you see here it's not giving you the data. The reason why, there's too many permutations. So for carb, we have too much data. It's hard to kind of see or to give us that analysis. For am, it's quite easy, and we see that it is significant. But, well, which is larger? Well, we can actually visualize that here. And you can analyze it as well. So we can see, again, by plotting this, so here we're plotting displacement and carb. We can also plot gear and see those values. So you see the displacement. So you can look and visualize with plots or just by analyzing the data itself. But here in the games how test, that's going to allow you, the eta squared gives us the size of the effect. Games how will tell us within each variable which experimental conditions are statistically significant, i.e. which variables bear bars overlap. But remember, this is working on a 95% confidence interval, so it may be different. That's why we want to actually look at that, that data and look at those differences. Fantastic. So we can now do the same for tooth growth. So I'm looking at 2A ANOVA dose and supplement on length. So we can go ahead and do the same thing. Remember setting the factor, setting the numeric values as well. So we can set that up. We can look and double check. We can get our summary of the data. So we see dose and supplement are indeed factors. We're working at 5% significance here. So as is the 2A interaction as well. Let's see what sizes. Large size, probably medium and small size effect. And then we can also see which are statistically significant between our values. So this p-value, 0.06, that's not going to cut it for our metric. This is significant, this is significant. And again, we can visualize that as well in our plots. We can drag that as well. So if I want the experimental condition of dose that gives me the largest length, I can look at that as well. So again, I want you to analyze that quite more thoroughly than I've done this in this video. So take some time to like walk us through that analysis. We can go back to empty cars. So now we're doing again a 2A VS and cycle will affect the weight. So we can do that. Again, setting these up, setting the numeric. We've got this here. Again, this is set up. Actually, this is set up as gear and carb, but we can set that up. Ooh, actually, where is it here? So, actually, let's go ahead and get this done right now. So we want to look at how. So we want VS, CYL, and how does that affect the weight? So we can delete this. So I want VS, I want this CYCL, and then I want as numeric, I want weight as dot numeric, and we're going to just delete this here. Set this up. Oops. Let's go ahead. Ooh, here we go. Let's go ahead. As factor CYCL. CYL actually probably. CYL WT. Oops. And then we don't want to get this. There we go. So now we can set up again. We want weight, and then squiggly, we want VS plus CYL plus VS CYL. So we can go here, click it. So we see the values. We can summarize this. So we see significant, 2A interaction is not significant. Large, not large. We can look at weight and then CYL. We can look at those variables. All of them are significant from each other. And then weight versus VS. Those two are significant from each other. And then we could even, again, plot it out. For example, weight versus, let's look at CYL. And we can actually look, again, if I want the largest weight or the smallest weight 4, largest weight 8, and we can see. So, fantastic. Let's do one more. Actually, 2 more. Let's look at orange here. So they're going to look at the orange data set. So we can do something very similar. So let's go ahead. The tree type will affect the circumference. So let's look at this. I'm actually going to just copy this. Do it twice. So we're going to look at, actually, there's 3. So let's do orange. Let's take a look at our data set. Capital. Oops, undo that. So orange, and we can see we have tree, age, and circumference. So what we want to look at, tree, and then circumference. So variable is going to be tree, and then our circumference. We're going to delete this because this is going to be a one-way ANOVA. So we're going to do as factor, and then we're going to actually do here as dot numeric, and we're going to do this as tree, and then we're going to do this as circumference, and then we're going to delete the rest here, and we're going to make sure to delete that. There we go. So now we can look at the summary of their data set. Looks good. So now we need to do circumference as, and our variable will be tree. And then we can get that set up. We can look at it. Tree is a significant factor. It has a large effect. And then let's go ahead and do circumference. And we're going to go ahead and do tree. And then basically 0 or 1. And it looks to be significant. We can plot it as well. Y circumference. And then we're going to do tree. And we can see if we want a large circumference. Ooh, actually, we actually want tree type 0. Excellent. And then finally, tree type now age. So we're going to run the same thing, but now with age. And we can actually change that quite easily here. So we're going to just change everything here. Tree type, the effect on age. Age, tree, age, age, and then age. Let's go ahead and set it all up. And then we'll get it. Boom, boom. Oops. Did I type it wrong? Nope, I did not type it wrong. Because I don't want empty cars, I want orange. Good. Tree type. Look at those. It doesn't look like it has a significant effect here. Tree as factor, as numeric. Good. Small effect. It's not significant here. Where is my... Sorry, I'm just double checking here. Hope we were using the same thing. I'm just double checking that we were doing okay last time. Let's do... Boom, boom, boom. Oh, actually, sorry, I think we may have made a mistake on the last one. So medium effect, and then the effect of circumference here. And then we can even plot this. Sorry about that. And we can see again, here, there's no significance really between them. They all overlap, so everything is kind of a null result. It's not significant. It doesn't have any effect on the circumference. If we now switch this to circumference to age, let's go ahead and do age. Let's do age, age, and age now. We can set this up. So let's do it again. Looks okay. Definitely not significant. Small effect, not significant, doesn't even exist there. And then if we look at the plot, it's exactly the same. So there we go. That's what we got. So we'll see you next time. Thanks. Bye.